In the event that you've continued on and solved this system by elimination, you've discovered something funny to happen. So whether or not you saw this 10 and this 5 and said, I'd like to make this a negative 10, or you saw this 6 and this 3 and said, I'd like to make this a negative 6 to combine with this, either way, you'd be multiplying by a negative 2, this second equation. And the 5a times a negative 2 would be a negative 10a. The 3 times a negative 2 would be a negative 6b, and the 2 times a negative 2 would be a negative 4. You'd add these two statements right here, the first and now the third statement, which was created from the second, and the 10a and the minus 10a is gone. And the 6b and the minus 6b are gone. But the 8 and the negative 4 combine to be 4. So when you eliminate the letters totally and you get a statement that is not true, there is no solution. That's the situation where the two lines are parallel and never intersect one another. So there is no answer if you looked at it graphically. If you got an answer where all the variables disappeared and you got 0 on the other side, that's the situation where there would be many solutions. So there are only two choices here by elimination. Is one, you get a statement that's not true and there's no solution, and so it's inconsistent. Or an inconsistent is the only time that there are no answers. Consistent is when there are answers, and in this case there are many, so it's a consistent system. It has some solutions. The next couple problems involve fractions, and they're pretty interesting. What you have to do is you have to look at each equation and discern what the common denominator is between a 3, a 4, and a 12. Now, I don't know that I've done this recently with you, but if the 3 goes into the 12, and it happens that the 4 goes into the 12, then the common denominator is 12. But another way to do this is to list multiples of 3, and I did this just recently, and multiples of 4, 4, 8, 12, and then multiples of 12, and once you get a number that's common to all of them, that's the one that we're going to use. Now what we're going to do is we're going to multiply both sides of this equation by 12. And what that does, notice right here, that's going to clear the denominator. You're just going to be left with an 11. I'm going to show you that when you multiply this by 12 and this by 12, that the 12 will be here as well. Now let's say you have some trouble seeing this because there's so much mess. Because really, 3 goes into 12 4 times, so you'd have 4 times 2 is 8x. But let's say you have trouble with that. Just go ahead and take 12 times 2x and get 24x over 3. Then you're going to see that that's an 8. 3 times 12 is 36y over 4, and you're going to see that's a 9. Here I'm not going to bother because it's so easy to see that the 12s will cancel out, and that's going to be equal to 11. I'm going to erase this now. So my first equation, 24 divided by 3, is going to be 8x. 36 divided by 4 is going to be 9y, and then equals 11. I'm going to do this second one differently. I'm just going to go ahead and do the reducing right away. So I'm going to multiply every term on the left side by 18. As a result, 3 goes into here once, into here 6 times, and you have 6 times x, which is 6x. Here, 18 divides into there once and into there once, and all you're left with then is 7y. And then finally, 2 goes into 2 once and into 18 9 times, and 1 times 9 is 9. And you now have such a nice equation to work with that rather than all that mess with fractions. And I think what I'm going to do is I'm going to go for, you know, you could just go for a 48 here, but 24 is the easier number. So if you'd multiply this equation by 3, and then maybe this equation by 4, but I'm going to multiply it by a negative 4, so that will become a negative 24. This will be the positive 24. So 8 times 3 is 24x. 9 times 3 is 27y. 11 times 3 is 33. Now the 6 times a negative 4 is a negative 24x. 7 times a negative 4 is a negative 28y. And 9 times a negative 4 is a negative 36. And now I'm going to add these equations where the x's will disappear, and I'll have a negative 1y, which equals, when those add together, I get a negative 3. When you divide both sides by a negative 1, you get y is a positive 3. Personally, I'm going into one of these equations with the y. Really doesn't matter which. So I'm going to go into the first equation, which is 8 times x plus 9 times y, which is 3, equals 11. I'm going to explain to you why I do this, because usually this is against the rules. And I'm going to subtract 27 from both sides. And 8x equals, let's see, this is going to be a negative 16. So when I divide both sides by 8, I get x equals a negative 2. I now have a solution, negative 2 comma 3. So normally when you get an answer for one of the variables, you're supposed to go back into an original equation. Well, I'm very confident in myself when I do this. Plus, I promise myself that I'm going to go back and check my answers. So let's see, my answers are a negative 2 and 3. I'm going to see if I can let this sit there. So my first equation was 2 divided by 3 times a negative 2. And then plus 3 divided by 4 times y, which is 3. And I get this decimal number. And then the right side of this equation was 11 divided by 12. And let's just see if those decimals are the same. So the left side turned out to be this. The right side was 11/12, and it checked. The next equation was x divided by 3. So I'm going to take x, which is a negative 2, and I'm going to divide that by 3, plus 7 divided by 18 times y, which was 3. And I want to know if that equals 1/2, which it does. So since I checked in my original equations, I'm very confident. Now if I were you, I would try this one on your own. So hit pause. Okay, so this one's a little bit simpler than the last one. The least common denominator between a 6 and a 2 is just a 6. So when I multiply this equation by 6, 6 times 1 is 6 over 2. 6 over 2 is, this will become a 3x. When I multiply this by 6, those 6's will cancel out, and the 3 has to be multiplied by 6. So again, if you need to see this, 2 goes into here once, into here 3 times. This first term turns out to be a 3x. Here the 6's cancel out, so I have a minus 1y. Go ahead and write the 1 if you'd like, if it make you feel better. And then on the right side I have 18. The common denominator between a 5 and a 2 is a 10. So I'm going to multiply both sides, including this 2, please, don't forget that. Just in case, again, you struggle. 10 times 2 is 20, divided by 5 will be a 4x. Here, 10 times 1 is 10. 10 divided by 2 is a 5y. And then on the right side, 2 times 10 is 20. Now I'm ready to solve the system, and I can see that I would like to make these 5's and negative 5's. So I'm going to multiply this equation by just the number 5, because that will make this a negative 5. But first, the 3 times 5 is 15x. The minus 1 times 5 is a minus 5y. And 18 times 5 is 90, I believe. And so we go to add these together, and 4x and 15x is 19x. 90 and 20 is 110. I'm going to divide both sides by 19, and I'll get x equals 110 divided by 19. Because that's such a nasty number to put in either here or here, I might start over again with this 3x minus y, and I'm going to do it right about here. So 3x minus the y equals 18, and 4x plus 5y equals the 20, and I think I'm going to make these become 12's. One of them positive, one of them negative. So I'll multiply this equation by a 4, And then I think I'll multiply this equation by a negative 3. So the first one, when I multiply it by 4, I get 12x minus 4 times y, and 18 times 4 I believe is 72. Right here, 4 times a negative 3 is a negative 12x, 5 times a negative 3 is a minus 15y, and 20 times a negative 3 is a negative 60. So I go to add these two equations together. The x's cancel out. I have a negative 19y right here. 72 minus 60 is 12. And when I divide by a negative 19, I get my solution for y of a negative 12 over 19. Put your negative sign wherever you'd like. My solution to the system is 110 over 19 and a negative 12 over 19. And I would pull my calculator out and I'd do that same calculation. So I'd take a half times this 110 over 19 minus 1/6 times the negative 12 over 19, and I'd hit enter and see if it equals 3. I have checked this, so I'm not going to do that for you right now. We'll come back and do some story problems.